हाँ ऑन कर दिया on it is on okay right done. So I think now you are having some of rough idea about earthquakes, certain aspects of geomorphic process, right? Volcanic activities, tsunamis, and those terminologies which are important in the context of your prelims and also in the mains parameters. Right. Now we move on to understand something about rocks. Then we will move on to weathering. Rocks and weathering. Now, if we take the earth crust, right? So atmosphere is different, earth crust is different. Crust means the surface area. And above this, we are having atmosphere. Above that, we are having atmosphere. Now, if you see the concentration of atmosphere, it consists of different gases, right? Now, which gas is dominant in the Earth's atmosphere? Nitrogen, right? So, when we talk about the element in the atmosphere, nitrogen is dominant. And after nitrogen, you are having oxygen, then carbon dioxide. That is in the Earth's atmosphere. Now, when we take a look of Earth's crust, in the Earth's crust, which element is dominant? In the Earth crust, which element is dominant? Oxygen followed by silica. Oxygen followed by silica. Sial, Sima, right? Oxygen followed by silica. Some rough ideas. Now, in the Earth crust, we find many elements are there. Oxygen is there, silica is there, magnesium is there. So, Earth crust consists of many elements. Many elements. Now, these elements combine with a different proportion. These elements combine with different proportions, and then they create the compounds, which we refer them as minerals. So they combine with different proportion and they create the minerals. Minerals. Is that clear? Now, among the minerals, when we talk about certain, we have certain minerals or few minerals which are very, very significant. We classify these minerals into different categories. Different categories. Like we are having the silicates, minerals which are classified as silicates. Now, can you give any example of silicates? Feldspar and quartz. Feldspar and quartz. So in the earth, we find different families of minerals are there. So one group is referred as silicates. Now in the same way, we also have oxides. Oxides. Oxides are nothing but ores of iron. Oxides, we refer them as ores of iron. Now example, hematite, magnetite, right? Example, hematite, magnetite. Right. Second group. Now, in the same way, we also have a group called as sulfides. We also have a group called as sulfides. sulfides, which are dominantly seen in the earth crust and which are also the ores. Now, any example of sulfide is galena, galena. Now, galena is a ore of lead. Lead is extracted from galena. Apart from that, we also have sphalerite. Sphalerite. Now, from sphalerite, which is extracted? Which metal is extracted? Sphalerite is an ore of zinc. Zinc. Zinc, sphalerite. Now, in the same way, chalcopyrite. Chalcopyrite, right? Now, what is extracted from chalcopyrite? Or chalcopyrite is an ore of copper. Copper. Right. So, in the earth crust, it consists of abundant elements, and among them oxygen is dominant, followed by silica, followed by aluminium, iron, etc. Iron, etc. So these elements combine with each other, and then they form the minerals. We have many families of minerals are there, and these minerals can be classified as silicates, oxides, sulfides, etc. And some minerals, they are in the free state as well. Some are in the free state as well. And these minerals, they consist of ores. And from these ores, metal is extracted. From these ores, the metal is extracted. So when you are reading, you should remember that metallurgy is a process associated with the extraction of the metal from the ore. Now, can we say all the ores are minerals? All the ores are minerals? Yes. Can we say all the minerals are ores? No. So, bulk of minerals are there in which you are having specific ores. From hematite, you can extract only iron economically. You can't extract copper from that. There is possibility, but it will not be economically feasible. Is it clear? No. So remember these things: elements, minerals, and then ores. Now, ore is a mineral from which a metal can be extracted economically. Ore is a mineral from which a metal can be extracted economically. So that's why in Indian geography, we'll try to understand mineral deposits. Mineral deposits. We'll see that when we take Indian geography, in which state which minerals are seen, which becomes a backbone of industrial development of that particular country, which is seen as one of the important aspect of foreign revenue. Exports and imports are also seen. Mineral, metallurgy, mining process, all these are very, very significant. Is it clear? Now, mining activity is a primary activity or secondary activity or tertiary activity? Mining, agriculture is primary activity. Mining is secondary, primary or tertiary? See, anything when you extract directly from the earth, we refer that as primary. So mining is primary activity. Now, when you convert that into iron and steel, that becomes secondary. So value addition to the primary products is referred as secondary, which includes manufacturing, industries, etc. Then service sectors. So many students make a mistake. Mining is a secondary or service sector. It is not secondary or service. It is primary activities. From the earth, when you are extracting the resources in its natural form, we refer that as primary activities. Agriculture, fishing, mining, all these are referred as primary activities. Is it clear? Now, when you become IAS officer, IPS officer, then that is referred as service sector, and within that quinary, quinaries, right? So you have different varieties of occupations are there: primary, secondary, then tertiary, quinaries. Quinary means government jobs and all. When you talk about tertiary, we talk about service oriented, like bank employees, etc. Right? So generally knowledge based industries, outsourcing, etc. And so we define them on the basis of occupation and how they contribute to the economic part. Right? So this is primary part, primary industry or primary sector. Is it clear? No. Earth crust, rocks, and these parts. Now, rock can be classified in different ways. Minerals generally they have certain physical properties and definite chemical characteristics. The definition, when we say based on their characteristics, minerals will have certain physical properties and definite chemical structures. When you talk about the rocks can be organic as well as inorganic substances. But most of the times when we classify minerals, we classify them as inorganic substances. But based on the usage, some minerals can also be organic, like fossil fuel, petrol, coal, they are also organic. So based on the usage, we can classify them organic. But based on the properties, we say minerals are inorganic substances which occur on the earth with certain physical properties and definite chemical characteristics. Whereas rocks consist of both organic as well as inorganic substances. Coal is a rock. Now, calcareous skeleton of coral is also rock. Calcareous rocks, that is organic. So rocks can be organic as well as inorganic. But minerals, when we classify, they are inorganic substances. But based on their usage, minerals can also be classified in the organic part, like fossil fuels, coal, petroleum, they are all called as mineral. Is it clear? So please understand the variations. Now, apart from this, referring rock as an organic and inorganic, we also classify the rock into three major categories: primary rock, secondary rock, and tertiary rock. That is igneous rocks, sedimentary rock, and metamorphic rocks. So we can classify the rocks into three major categories: igneous rocks, and these igneous rocks are also referred as primary rocks. So these are the first rocks which are developed or produced after the volcanic activity. Igneous rocks. Then the second category of rocks, we refer them as sedimentary rocks, sediments, broken part, sedimentary parts. They are also referred as secondary rocks. And they are also referred as stratified rocks. Broken sediments. So when the broken rock sediments compactly arranged, we refer that as lithification. When the broken sediments, see, you are having, so when you talk about this chair, it is made up of particles of the wood which are compactly arranged, right? Like close bonding. In the same way, when different sediments of the rocks, when they compactly arrange, we refer that as lithification. And that creates the sedimentary rocks. That create a secondary rocks. That is compact lithification. Lithification means clubbing them. Different particles of the different rocks, they club, they lithify, then they create the sedimentary rocks. Is it clear? So sediments, small sediments combine and lithify, secondary rocks. Then the third category of the rocks, we refer them as metamorphic rocks. Metamorphic means they are also referred as tertiary rocks. Morphic means changes. Changes. You understand? Here. Sedimentary rocks can be derived from igneous rock. Sedimentary rocks can be derived from metamorphic rocks. So hence they are referred as secondary rocks. Then, when you talk about metamorphic rocks can be derived from either igneous rock. Metamorphic rocks can be derived either from sedimentary rocks, or metamorphic rocks can be derived from existing metamorphic rocks. They can be derived from existing metamorphic rocks. Is it clear? Original rock, igneous rock, it can create sedimentary rock. Broken metamorphic rock can also create sedimentary rock. Now this igneous rock can undergo change and become metamorphic rock. Sedimentary rock can undergo change and become metamorphic rock. Existing metamorphic rock can also undergo change and become metamorphic. Morphic means change. Change in their physical and chemical properties. So when we say metamorphic, so they change their physical properties or chemical properties or both. So change in the physical property or chemical property or both. Such rocks we refer them as metamorphosed, changed rocks. Is that clear? Now among these three rocks, only sedimentary rocks are the layered rocks. Stratified means layered rocks. Layered rocks. So sedimentary rocks are layered rocks. Layered rocks. Whereas igneous rocks are crystallines. Crystals, they do not have any layers. So they are crystalline rocks. No layers. No layers. Is that clear? Now, sedimentary rocks, when they are layers, it means that they can accumulate dead plants and animals. So hence sedimentary rocks are the only rocks which consist of fossils. Sedimentary rocks, thank you. Sedimentary rocks are the only rocks which consist of fossils. And the petroleum coal which we extract from this, we refer them as fossil fuels. The petroleum, the coal, the natural gas, what we extract is referred as fossil fuels. And it is from sedimentary rocks only, not from igneous rocks, not from metamorphic rocks. Because igneous means, igni means fire. And if a temperature of 1000-2000 degrees is there, then all the dead plants and animals will burn off. So hence igneous rocks will not have any fossils. They are crystalline rocks of different sizes. Sedimentary rocks, stratified rocks. With the fossils, layered rocks. Layered rocks. And these are economically valuable rocks like diamond, marble, rubies, etc. So economically valuable, granite, diamond, right? So economically valuable one, metamorphic, right? From carbon, graphite is formed, lead is formed. Is it clear? So this is a rough idea about the rock in a simple flow. Now we'll try to understand some characteristics of these rocks. Is it clear now? A general picture, igneous, sedimentary and metamorphic rocks. Now, if you take the earth and other parameters, if you take entire rocks on the earth, entire rocks, lithosphere on the earth, 100% as the rocks. Remember here, out of the total rocks, 3/4 of the total rock or 75% of the total rock is sedimentary rock. Right, but these sedimentary rocks are not visible through the naked eyes. Why? Because they are deposited in the layers in the oceans, lakes, or inside the valleys. But maximum number of the rocks are sedimentary rocks, which makes 75% or 3/4 of the total rocks. The rocks which we see through the naked eyes, they are all igneous rocks, not the metamorphic rocks, not the sedimentary rocks. Sedimentary rocks are dig inside the ocean, coastal areas, river valleys, where fossils are there, right? So even though 75% of the rocks are made up of the sedimentary rocks, most visible rocks to the human eyes are the rocks which are there on the earth crust. And earth crust is made up of 85 to 90% of igneous rocks. Understand this. Earth crust, upper portion, without breaking, we refer that as earth crust. So earth crust is made up of 85 to 90%, or we say 80 to 90% of igneous rock. Unbroken rocks. But earth's surface where the rocks deposit in the lakes and all, 90% or say 75% is made up of sedimentary rocks. On the earth surface means which includes the lakes, which includes the rivers, which includes the soil deposits. On the earth surface, the maximum rock deposits are sedimentary rocks. On the earth crust, only the upper portion, the maximum rocks are igneous rocks. These igneous rocks, when they break, they enter into rivers, then they deposit, then they become sedimentary rocks. Is this clear now? On the earth crust, the dominant rocks are igneous rocks. On the earth's surface, the dominant rocks are sedimentary rocks. Among all the rocks, the maximum rocks are sedimentary rocks only. Sediments of broken rocks. Is that clear now? These characteristics you should remember. These characters you should remember. Okay. Now moving down to very small idea about the igneous rocks. I'll explain that. So these are perspectives. Metamorphic, I'll explain. Is it clear now? Igneous and sedimentary. Okay. Now moving down to igneous part. These are the primary rocks. These are the primary rocks. And in Greek, igni means fire. So they are released by volcanic activity. They are released by volcanic activity. Now, based on their chemical composition, these rocks are classified into two major categories. Now, chemical composition means chemical composition of magma. Chemical composition of magma. Because this magma solidifies and become lava. Now, magma means we have to compare silica, high silica or low silica. So, based on the magma, if it is having high proportion of silica, high proportions of and low proportion of silica. Low proportion of silica. Now understand here. If it is having high proportion of silica, it means it is acidic. 55 to 65% of the silica. It means such rocks are acidic rocks. High proportion of silica, it means they are acidic rocks. And such rocks are referred as felsic rocks. High silica, felsic rocks. Felsic rocks. So what does felsic means? Felsic means feldspar, silica and oxygen. Felsic, feldspar, silica, oxygen, etc. So as they are having feldspar, oxygen, etc., so they are light colored rocks. Light or white colored rocks. And it means that they are having less densities, low density. and they are hard rocks. Low density and they are hard rocks. Now, can you give any example of that? Granite. Granite. Right. Now, if any rock is having low silica, then it is called as basic rock. Basics. And such rocks are referred as mafic rocks. Mafic rocks. So the moment when you say mafic, it means that it is rich with manganese and iron. Ferrous. Ferrous. Now, because of presence of ferrous and manganese, it will be white color or dark color. Dark color, black color, dark color. Dark color. And iron, manganese are there. They will be having high density. High density. Denser. And they are comparatively softer. Comparatively softer. And the best example of that is basalt in the ocean beds. Basalt. And Gabru rocks. So we refer them as Is it clear now? So high silica and low silica part. Is it clear? And the most denser rocks where the proportion of silica is comparatively still more or less, we refer them as ultramafic rocks. Mafic means denser. More than that, we refer them as ultramafic rocks. Ultramafic rocks. So they will be still below the oceanic crust. So we are having silica rocks, mafic rocks, ultramafic rocks. Is that clear? So that's why oceanic crust is basalt. Sial is made up of these. Is that clear now? So high silica, low silica, and ultramafic. Ultramafic are such rocks which are heavily density and high proportion of ferrous will be there. They will be at depths. Is that clear now? So this is based on the chemical composition. Is it clear? One aspect of igneous rock. So the moment when we say felsic rocks, you should immediately bring the things into mind. Felsic and mafic rocks. I hope you will remember this. Felsic and mafic. Right. Second one is where the magma is deposited. That is place of deposition. This is one way of classifying the igneous rocks. Second one is where the magma is deposited. Now understand this. So based on the deposition of magma, it can be above the earth surface or it can be below the earth surface. See, this is magma chamber and this is the surface of earth. Now sometimes this is the vent of the volcano. Now sometimes we find the earth will have different cracks. So the magma will deposit in the cracks. And sometimes the magma will reach to the surface. Now based on the position where the magma is deposited, if it is deposited outside, we refer that as extrusive igneous rocks. Extrusive igneous rocks. If they are deposited inside the earth, then we refer them as intrusive. We refer them as intrusive igneous rocks. intrusive igneous rocks inside the earth surface. Now, here understand, if they are deposited intrusive and if they are deposited near the surface, if they are intrusive near the surface, such intrusive rocks which are deposited near the surface, we refer them as hyperbasal rocks. Hyperbasal rocks. Intrusive rocks deposited near the surface but inside, we refer them as hyperbasal rocks. Hyperbasal rocks. And intrusive rocks which are deposited at great depth, we refer them as plutonic rocks. Plutonic rocks like batholith. Now, igneous rocks can be different ways. If they deposit in the form of ribbon, then we refer that as phacolith. Right. If they are deposited in the form of saucer shape, lapolith and lacoliths. Lapolith and lacolith. If they are deposited in the form of mushrooms, stalks. Near the surface, dikes. Hyperbasal, example, dike. This is dike. So this is how the igneous rocks are seen. One is based on the composition. Second one is based on where they are deposited, extrusive and intrusive. Extrusive and intrusive. Batholiths, lapoliths, lacoliths, stalks, they all are intrusive rocks. And above that, we are having extrusive rocks. Is that clear now? Now, if you take the area, this is extrusive rocks, this is hyperbasal rock, and you are having plutonic rocks. The magma will be same. The magma will be same. Now, where do you find the magma? The same magma will become solidify very fast at A, B, or C. At A, it will become solid very fast. So here you will have small rocks. C, it will take more time. So hence, more magma will be deposited. So hence, where do you find the biggest rocks? At extrusive, hyperbasal, or plutonic? So plutonics are the biggest rocks, as it takes more more time to cool. So plutonics are the biggest rocks. Is that clear now? Plutonics are the biggest rocks. Is it clear? So remember this image. So if any question is asked, try to write them. And igneous rocks, no fossils, no layers. No fossils, no layers. Is it clear? Now, second type of rocks, we refer them as sedimentary rocks. Second type of rocks are sedimentary rocks. Okay. Sedimentary rocks. Now, in the context of sedimentary rocks, these sedimentary rocks makes the major portion of earth crust. Sorry, they make the major portion in the earth surface. Now here, igneous rocks makes the major portion of earth crust. Igneous rocks makes the major portion of earth crust, whereas sedimentary rocks on the surface of an earth. 3/4 of the rocks or 75% of the rocks are sedimentary rocks, but they all are hidden. You can't see them. Now, the process involved here is a big rock, when it breaks, we refer that as weathering of a rock. Weathering of a rock. This weathered rock is later transported, and then it is deposited either in the river valley or in the lake or in the ocean or in any inland area. So it is deposited layer by layer. And this deposition is very compact deposition, and we refer that as lithification. Lithification. And such rocks, we refer them as the sedimentary rocks. So as they deposit layer by layer, so sometimes dead plants and animals will be there. And hence, these are the rocks which consist of fossils. And these are the rocks which provide fossil fuels like carbon. So the dead plants and animals under particular temperature and pressure, under certain temperature and pressure, they convert themselves into either petroleum, coal, natural gas, etc. We refer them as fossil fuels. So the process involved is weathering, transportation, compactness, and lithification. We refer that as sedimentary rocks. And on the earth, we always know that 75% of the rocks are sedimentary rocks. Is it clear now? Now, sedimentary rocks can be classified into 3 major categories according to your NCERT books. If it is optional, then you have to dig more. If optional, you have to dig more, or else NCERT books are sufficient. So sedimentary rocks, we can classify them into 3 major categories. The one categories, we refer them as clastic rocks. We refer them as clastic rocks or clasts. Clastic sedimentary rocks, CLAST. So what are clastic rocks? So clastic rocks are the rocks which are formed by fragments of pre-existing rocks. Fragments of pre-existing rocks. They are formed by fragments of pre-existing rocks. Existing rocks. We refer that as clastic rocks. Right. Example, sandstone. Now, the second one is referred as chemical process. Now, generally, when you talk about the chemical process, so here it is seen in the oceans, rivers, lakes, etc. So the amount of dissolved mineral in the lakes, rivers, etc. Amount of dissolved minerals in the rivers, lakes, etc. They become saturated. It is something like this. If you are taken up 2 biryanis, after that you are saturated. Now, after that again, if you take some extra food, what will happen? Whatever you have done, you will omit, you pick, right? You puke up that. Now the same thing happens. Amount of dissolved minerals in the rivers, when they become saturated, so what will happen? So they will release the minerals. So these areas, when they saturated, then the minerals will precipitate out. So after reaching to the saturated, so the minerals will precipitate. The minerals will precipitate, release, and then lithification, compact and lithification. So they will make compact and lithification. And such rocks are referred as the chemical rocks. Example, gypsum. Example, gypsum. Is that clear? So we refer them as chemical process of sedimentary rocks. Then the third one is referred as organic part. Third one is referred as organic part. Organic sedimentary rocks. Now, the moment when you talk about organic, so it is lithification of dead plants and animals. It is the process where lithification includes the dead plants and animals. Dead plants or animals. Example, coal or calcium carbonate, calcareous skeleton of coral. Coral reef is a calcareous rock. Coral reef is a calcareous. Is that clear? So we classify them into three major categories. That is classed, chemical, and organic. And these sedimentary rocks are layered rocks. They have the fossils, which can be used for generation of fossil fuels. Is it clear now? Now, the last category, we refer them as metamorphic rocks. Right? So when you're reading, keep these things as simple as possible. Because general studies is something different from your optional. Now, if you keep on preparing your general studies like optional, then it becomes very difficult. Is it clear? It is something like this. Some 5 years back or 10 years back, when you say 5 years back, when you talk about generally we say Amir Khan is perfectionist. Not now, generally we say perfectionist. It means that if any mistake is there, he used to take 10 shots. So your optional should be microanalysis. Microanalysis should be done in the optional. But your GS should be macroanalysis. If you start changing your perspective, then your preparation will become a major problem. Is it clear? So macro analysis should be there in your GS. Micro analysis should be there in your optional part. Is it clear? So then only you can write very good answers. If you change your approach, then it becomes a major problem. Is it clear now? Now the last one is metamorphic rocks. Last one is metamorphic rocks. Now understand here. Any rock, I'm using the term any rock. It can be igneous, it can be sedimentary or existing metamorphic rock. Any rock, either igneous or sedimentary or metamorphic rock. Any rock which undergoes either physical change or chemical change or both. Any rock which undergoes either physical change or chemical change or both. And these changes are either permanent or temporary. Permanent or temporary. Such rocks are referred as metamorphic rocks. Any rock which undergoes change in the physical property or chemical property or both, and either temporary or permanent. We refer them as metamorphic rocks. Now here we talk about change is more specifically in its physical properties and change in its chemical property. Change in physical property is because of pressure. And change in chemical property is because of temperature. And when you talk about both, then both are combined. Both are combined. Now, understand this. This is a rock. This is a rock. Now, you are applied pressure from all the sides. You are applied pressure from all the sides. If you apply from one side, the rock may shift on other side. If you apply from three sides, the rock may break. When the pressure is applied from all the side equally, we refer that as isostatic pressure. Isostatic means balance. Isostasy means balance. So when the pressure is applied with isostasy, what will happen to the size of the rock? It will shrink. Perfect. So this rock will shrink. Now the moment when the rock has shrink, what will happen to its density? Will it remain same, decrease, or increase? Increase. That is called as physical property. So in the physical property, due to applied pressure, the density of rock increases. Its density increases. Is that clear? Density increases. Now in the same way, when the rock is there, maybe because of any magma when it is moving from the Earth's interior, this magma will always have high temperature. So this magma, when it comes in contact with the rock, then it will change its chemical composition. So temperature is responsible for changing its chemical composition. Is that clear? So either due to pressure or due to temperature or due to both. Right? And hence, based on these, the metamorphism can be three types. Based on this, the metamorphism can be three types. Right. So generally we refer them as contact metamorphism, then regional metamorphism, and dynamic metamorphism. Dynamic metamorphism. And third one is regional metamorphism. Very simple to remember. Regional metamorphism. Now, in the context of contact metamorphism, contact means the magma when it comes in contact with the rocks. So in contact metamorphism, which is changed, physical or chemical property? In contact metamorphism, chemical property is changed or physical property is changed? Chemical property. So here in the contact metamorphism, temperature is dominant. Temperature is dominant, and it will define change in their chemical property. Chemical property. Right. In the dynamic, it is pressure which is dominant. Pressure which is dominant. So hence it will change its physical property rather than chemical, physical property, density part. So it will change more of its physical property. Now there are certain areas like beside Himalayas, like big mountains are there, large mountains are there, the rocks there, or big areas of large earth crust. So in that areas where both factors are dominant, temperature as well as pressure, so we refer that as dynamic metamorphism. So below the mountains and all. Sorry, we refer that as regional metamorphism, where both are dominant, pressure as well as temperature, where the rock undergo change. We refer that as the regional type of metamorphism. Is that clear now? So hence, these rocks, when they change, they become economically valuable, like the carbon or coal converting into diamond. Many such examples are there. Diamond is a metamorphic rock. Granite is a metamorphic rock. Marble is a metamorphic rock. Granite is a metamorphic rock, right? And they are economically valuable rocks. They are economically valuable rocks. Remember 1, 2, that is more than sufficient. Yeah. Here, both will be there, not regional, sometimes only due to temperature, sometimes due to pressure, or both are applied. Is it clear? Rough ideas how the rocks are classified, right? Now, next we move on to a process called as weathering of the rocks. Weathering of the rocks. Right. Now, weathering means breaking of the rocks. Or we use the term disintegration of the rocks. Breaking of the rocks or disintegration of the rocks. Now, before moving down to this weathering process and all, these rocks, the rock can be hard rock or the rock can be soft rock. Now, which rock can break very faster? The soft rock. So this is simple. Soft rock undergoes weathering very fast, and hard rock will take more time to disintegrate. That is one. This is one way of classifying the rocks. Other one is igneous, sedimentary, and metamorphic. The third way where you can classify the rocks are, if you take sponge and duster, if you dip them in the water, which will absorb the more water? Why? More porous. So rocks can be classified on the basis of porosity and permeability. So there are certain rocks where we say they are having porosity. Porosity, the rocks, if they are porous, they will absorb water. If the rocks are permeable rocks, they allow the water to pass through. Permeable rocks and non-permeable rocks. Permeable rocks will allow the water to pass through. Right, so permeable and non-permeable rocks. Right, so weathering. The moment when you talk about weathering, understand that the climatic conditions on the earth, are they uniform? And the composition of rocks, are they uniform? So as the climatic conditions are not uniform and the composition of rocks are also not uniform, then can we expect all the rocks break in uniform way? So hence the rocks break in different ways. That should be kept in the mind. Their composition is not uniform. Their chemical, climatic conditions are all not in the same way. So hence we find they always have variations. We classify all the weatherings into 3 major categories. The one is called as physical weathering, or we refer that as mechanical weathering. Second one is referred as chemical weathering. And the third one is referred as biological weathering. Now understand here. The moment when we take about the physical weathering, in the physical weathering, the big rock disintegrates and there will be no change in the chemical composition. So in the physical weathering, the big rock disintegrates. This is the big rock. It breaks. So hence there is no chemical change. No chemical change. We refer that as physical weathering. There is no chemical change. We refer that as physical or mechanical weathering. All rocks can undergo physical weathering. All rocks can undergo physical weathering, right? Now, physical weathering, the moment when you say, it consists of different names. The first one is exfoliation. Then we are having granular disintegration. Granular disintegration. Then we are having block separation. Separation. Then we are having shattering. At least few you remember. Exfoliation, granular disintegration, block separation, shattering, or frost action. Frost action. So these all are examples of the physical weathering. Now, try to understand this. If the rock is made up of different minerals, A, B, C, D, different minerals. Every mineral will have different response to the particular climatic condition. So whatever climatic conditions are there, so if this rock breaks grain by grain, if this rock breaks grain by grain, so A is broken, B is broken after some time. So grain by grain separation in the form of spherical balls, in the form of spherical balls. We refer that as granular disintegration. It is by that rock which is having different mineral composition, no uniform, multi-mineral composition. Is it clear? Different minerals. So such rock will undergo granular disintegration. Right. Now, if you find any rock which is having same or uniform chemical composition, so it will undergo exfoliation. It is something like this. When you visit to the parlor, they will apply cream. When you ask for facial, then they remove layer by layer, peeling off. Or when you cut an onion, layer by layer separation is done. So such type of layer by layer separation is referred as exfoliation. So it is called as peeling off rock, or it is also called as layer by layer separation, right? If it is uniform mineral composition. Then block separation, generally this is seen in the areas like young mountains, where different series of rocks are there. In that, as they are in the beginning stage, one rock falls from that. So in the mountain areas, series of rocks are there. So in that, this rock falls down from that. It separates from that. Big rock separates from that. We refer that as block separation. Then sometimes when the big rock breaks in the form of sharp edges, in prehistoric times, they were used as tools for hunting, microliths. So such type, when the rock breaks in the form of sharp edges, we refer that as shattering. Now, there are certain rocks where we find big rocks are there, and in that they have layers. I'm using the term, sorry, cracks, not layers, cracks, not the layers. So in this cracks, generally in the desert areas, during rainy season, the water enters here. And in the desert areas, the temperatures are extreme. In the daytime, the temperature is very high, and in the night time, the temperature becomes very, very low. So this water undergoes the two process, freezing and melting. So it freezes in the night and it melts in the daytime. Now, any water, when it freezes, its volume increases. So that's why in the winter season, many pipes burst because of when the water is converted into ice, its volume increases. So that's why icebergs float on the water. Icebergs float on the water. Their volume increases. Their volume increases. So hence, the moment when the water freezes, its volume increases. And again, when it melts, its volume decreases. So this will create pressure on the rock. And by that, the entire rock breaks. We refer that as frost action. Frost action. So these are the different ways in which the rock breaks. Exfoliation, granular disintegration, block suppression, shattering, and frost action. Is it clear? Block suppression. This is block suppression. Right, series of rocks are there. So this separates from the, it is something like this. You are having steps to the upper floor. So in that, one brick falls away from the step. That is called as block suppression. Right. So this is granular disintegration, different minerals, exfoliation, uniform mineral composition. This is block suppression. This is shattering, breaking in the form of sharp edges. Is it clear now? Okay. Now, the second one is what we refer them as the chemical weathering. Chemical weathering. Now, what happens in the context of chemical weathering? Chemical weathering. Now, chemical weathering is done by most of the time, chemical weathering is performed by layered rocks. And which are the layered rocks? Sedimentary rocks. So igneous rocks, do they have layers? So igneous rocks cannot perform chemical weathering. Igneous rocks can be broken only by physical weathering. Is it clear? Or biological weathering in the cracks when the roots enter. So igneous rocks cannot undergo chemical weathering because they do not have layers. Sedimentary rocks can undergo chemical weathering because they are having layers. So in the beginning, I use crack, not layer. Right? So chemical weathering, a big rock is there. Big rock is there. Now it is having layers, different layers, right? Now in the chemical weathering, you should understand that the rock breaks into small part and it will also change the chemical composition of parent rock and broken rock. It will also change the chemical composition, change the composition of the parent and broken rock. So hence, it is also referred as decomposition. So chemical weathering includes disintegration as well as decomposition. So chemical weathering includes disintegration and decomposition. And as there is a change, so chemical weathering is faster than physical weathering. It is faster than physical weathering. Is it clear? Faster. The rate of chemical weathering is faster than that of physical weathering. Now, in the layers, sometimes when the water enters, water means H2O, enters into the layers. Now, these rocks may consist of different minerals or different elements. It may consist of calcium, or it may consist of sodium, or it may consist of ferrous, iron, etc. Big rocks. Now this water, when it enters into the layers, Now sometimes this hydrogen part combine either with calcium or with sodium, and it convert that into mild carbonic acid. It convert that into mild carbonic acid. And this process is referred as carbonation. This process is called as carbonation. And by this, the rock breaks very faster. Carbonation. Now, sometimes, if the rock is having ferrous, so the oxygen part of the water, it combines with the ferrous part, and it will create ferric oxide, rusting of iron, red colored, brown colored rocks. So it will create ferric oxide, that is rusting of iron or rusting of the rock. And we refer this as oxidation. We refer this as oxidation. Is that clear? So carbonation and oxidation, example of chemical weathering, where the rock undergoes physical as well as chemical change. Physical as well as chemical change. Is that clear? Right. So physical, chemical, then the last one is biological. So biological means because of living animals like human beings, burrowing animals, and roots of the trees. Roots of the trees. We refer that as biological weathering. So in the biological weathering, human activities like mining, roots of the plants when they enter into the cracks, roots when they enter into the cracks, right? Or many burrowing animals, like rabbits, rats, etc. When they enter into the cracks of the rocks, then they slowly disintegrate that, right? So hence we have biological weathering also. So these are referred as the major types of weathering. Is it clear? So biological weathering, physical or chemical weathering, sorry, physical or mechanical weathering, and chemical weathering. Clear? So igneous rocks can undergo physical weathering, but not biological weathering. Sedimentary rocks are more suitable for chemical weathering because of layered. Is it clear now? Okay. Is it clear regarding the weathering process? Okay. So I think almost all the perspectives have been done. Now regarding theory, which is not significant for your prelims, but still I'll make an understanding of that difference between the theory. The first theory is referred as continental drift theory. And this theory is given by Alfred Wegener. And this Alfred Wegener, he explains the theory by using the two terms, the supercontinent called as Pangea, and this Pangea was surrounded by big ocean called as Panthalassa. Pangea and Panthalassa. He says that this is somewhere around 300 million years to 250 million years. He says that this Pangea broke away. He has not explained any reason for breaking of Pangea. Broke away. And after breaking, because of the two forces, the first one is differential gravitational force. And second one is centrifugal force. So these two were responsible for drifting of the broken plates, movement of the plates. So these two were responsible for movement of the plates, one towards the north and one towards the west, and one towards the west. And he also gives the idea of landforms. The westward movement is responsible for creating the mountains like the North American mountain, Rockies and Andes. So he says that this westward movement is because of centrifugal force. And this created the mountains here. So when you talk about the mountains here, right? So he says that the westward push is responsible for creating Rockies, Andes, and Caribbean islands, West Indies and all, Caribbean islands. And this western push is also responsible for creating an ocean here. Which is that ocean? In between North America, South America, and Africa. So here you are having the African part. This is Mediterranean Sea. And here you are having this entire portion, right? This is Arabian Peninsula, right? And then India, something like this, right? Australia, right? So here it has created an ocean. We refer that as Atlantic Ocean. So western push is responsible for creating Atlantic Ocean, Rockies, Andes, Caribbean islands. And he also says that the northward push is responsible for creating this water body. Which is that water body? Indian Ocean. Northward push is responsible for Indian Ocean. And it is also responsible for formation of mountains here. Which mountains? Himalayas and Alps. Himalayas and Alps. Is it clear? So this is what the continental drift. Two forces, and he has taken many evidences to that. Zigs of it, then fossil deposits, tillite deposits, coal deposits, right? So he has taken evidences of that. But the major critics to this theory, major critics or drawbacks to this theory, is that he was unable to explain the reason for breaking of Pangea. He was unable to explain. Critic is unable to explain the reason for breaking of Pangea. Right. And second thing is he was unable to explain the magnitude of these forces. He was unable to explain the strength and magnitude of these forces, because mathematically, if you calculate, mathematically and by using physics, if you calculate the magnitude or strength of centrifugal force or differential force, that would have stopped the Earth's rotation. That would have stopped the Earth's rotation. And Earth has never stopped its rotation. So hence, he was unable to explain the magnitude and intensity of these two forces. He was unable to explain the magnitude and intensity of this force. So this is the summary of the continental drift theory. And when you are writing, if you remember this, that is more than sufficient. Is it clear now? So supercontinent, Pangea, two forces, and its evidences and its suggestion. Right. So for the first time, he tries to explain the movement of plates. Now, this is something where he says that whatever he says is correct, but the mechanism is not correct. Whatever point he says, it is correct, but the mechanism is not correct. It is something like this. If I say, I have traveled from Hyderabad to Delhi in 3 hours. I have traveled from Hyderabad to Delhi in 3 hours. It is not a magic. It is true or not? This portion is correct. But if I say I have traveled from Hyderabad to Delhi in my old Maruti 800 car, is it true? Half portion is true, half portion is wrong. That is the story of continental drift theory. The first part that you have reached in 3 hours, that is correct. But the mechanism of using Maruti car is not correct. So how you have reached in 3 hours? By using flight on plane. And that mechanism was explained by plate tectonic theory. Mechanism was explained by plate tectonic theory. In the plate tectonic theory or sea floor spreading, they says that what is the reason for movement of lithosphere plates? Convection currents. That's it. Is that clear? So hence, when we talk about continental drift theory, you can't reject that because he has sown the seeds that yes, you can reach there, and he has given the truth. You have reached there in 3 hours, 4 hours. It is true, but the mechanism which is explained by him is not correct. So hence, half of the portion of continental drift theory is correct, but the explanation given by that is not correct. And that explanation is corrected by concept of seafloor spreading and plate tectonic theory. Right. So what is the reason for breaking up of Pangea? Convection currents. It is something like big rocks are there, continuously heating, Pangea will break. After breaking, they will start making drifting. Right. So this is what you have to understand. So continental drift theory, even though it is having critics, but yes, it is important due to the facts that it opened an investigation where it talks about the movement of the continental crusts. And based on the further paths, it has been rectified. And there you should understand the rectification is done by the two important parts. One is seafloor spreading concept, and the last one is the plate tectonic. Right. Now in the plate tectonic theory, always remember, it talks about convergent plates. In the convergent plates, if it is a continent and continent conversion, it will create only fold mountain. It will create only fold mountains only. If it is continent and ocean, so ocean crust will subduct, it will create mountain, that is fold mountain, along with volcanic activity. Example, Rockies and Andes. Continent and continent, example, Himalayas. Continent and continent. So here you have earthquake but no volcano. So these are associated with earthquake but no volcano. These are associated with earthquake, they are associated with volcanoes, Rockies, Andes, etc. Now the third combination is oceanic and oceanic. Relatively denser plate will subduct, like Indian Ocean and Pacific Ocean. So it will create a group of islands which are scattered there, volcanic island arcs. So it will create volcanic island arcs. Volcanic island arcs. Group of islands which are scattered there, like Indonesia, Philippines. Right. So generally we refer them as archipelago. Archipelago means group of islands. Archipelago. So this is convergence of the plates. Now convergence will always reduce the land. We refer that as destructive in the nature. So convergent plates are always destructive. They are always destructive. Is that clear now? Divergent plates. When you talk about divergent plates, so divergent plates means the two plates are moving away from each other. So it means they are constructive in nature. Constructive in nature. So whatever is lost here is done here. So there is maintaining that. So whatever is created is destroyed here, or whatever is destroyed here, it is created. So that's why the earth maintains its shape and size. Now this creates, when we talk about divergence, it creates ridges in the ocean, it creates rift valleys, it creates rift valleys, it creates the lakes like Red Sea, tectonic lake, right? Lakes, Red Sea, etc. Arabian Peninsula, all these are divergent plates. Arabian Peninsula, detaching from Africa and reaching there. So convergent and divergent. And the last one is when they move parallel to each other. When they move parallel to each other, we refer that as transform plates. Transform plates. So in the transform plates, neither the land is created nor the land is destroyed. So only in these two it is created or destroyed. So here they do not create any land nor destruction. It is like strike slip. Strike slip. And example of this is San Andreas fault. San Andreas. And always remember, such types of movements, they are always associated with shallow earthquakes. Always. They are associated with shallow earthquake. Myanmar, Turkey, they all are such types of movements. Shallow earthquakes. Right? So these are referred as three types of the movement. Convergent, divergent, and then transforms. Is it clear now? So please remember these. Continent and continent will have different impact. Ocean and continent will have different impact. Then ocean and ocean will have different impact. Ocean and ocean will have different impact. Sea and sea, C and O, O and. Is it clear now? Okay. Now, when we talk about few questions which were there, few questions which were asked in PYQs. Right. The first question is, consider the following statement. Rainfall is one of the reasons for weathering of the rocks. Right. Water. Whether it is physical, chemical, he is asking one of the reason for that. Rainwater contains carbon dioxide in its solution, CO2. Rainwater contains carbon dioxide in its solution. When the rainwater combines with the carbon dioxide, it will have solution of that. The rainwater always combines with them and create the solution when it enters into the layers. Then, rainwater contains atmospheric oxygen. Oxygen will be there. It will absorb oxygen. It will absorb carbon dioxide. Carbonation. Carbonation. Oxidation. Right. Now, which one of the following correct in respect to the above? Both the statement 2 and 3 are correct, and both of them explain the statement 1. Statement 2 and statement 3 are correct, but only one of the statement explains the statement 1. Only one of the statement is correct. So when you see these things, chemical weathering, if you take, both the statements are correct, and both defines which type of weathering? Chemical, that is disintegration as well as decomposition. So that means that the first option is correct here. Both the statement 2 and 3 are correct, and both of them explains the first statement, which is referred as chemical weathering. Is it clear? So you should be good enough in analyzing and answering the question. Right. Now, next question. Consider the following statement. In seismograph, P waves are recorded earlier than S waves because of their high velocities. Then, in P waves, the individual particles vibrate to and fro in the direction of wave propagation, whereas in S waves, the particles vibrate up and down at right angles to the direction of wave propagation. P waves, how they move? Straight line or straight line, longitudinal. S waves, I told you that they move something like this, up and down, right angles with that. So what will be the answer for this? Fourth or second or third? Consider the following. Which of the following statements are correct? C. First is also correct and second statement is also correct. Is it clear? Both the statements are correct here. In seismograph, P waves are recorded earlier. P waves individual. So if they ask, sometimes when you are reading, which of the following statement given are incorrect, then you have to go for D. So you should be reading them carefully, because many students in curiosity, the moment when you read this, sir has told, I'll mark it, both are there, both are correct. But after that, you will realize that which of them are not correct. Then you can't recorrect your answers. So many students make a mistake. Many make a mistake of curiosity and they blindly mark it. Afterwards, they will realize. So at least out of 100, 5-10 mistakes you will do like that. And that is more than sufficient for the exam to keep you away from opportunity to write the mains. So it is not about knowledge, it's about your presence of mind. It is about how patiently you are reading every word and how you are understanding the question. So if you are having patience, if you are understanding that, I think there will be no problem for you to write a very good approach here. So you should be reading them very correctly, because suddenly curiosity will be something which is problem. It is something like this. 2 live wires were there. One crow was sitting on one live wire, one crow was sitting on other live wire. So they were not feeling any punch of the electricity. But curiosity was there. What will happen if I touch your beak? So when they start touching each other beaks, so then the current passed there, both went collapse. So it should not be like that. It should not be like that. I hope you are getting the point, right? So when you are there, you should kill your curiosity, enjoy on which wire you are sitting, and complete the process. That's it, right? Okay. Now this question. The Barren Island volcano is an active located in the Indian territory, erupted in 2018. Barren Island lies about 140 kilometers east of Great Nicobar. Nobody exactly remembers that. The last time the Barren Island volcano erupted was in 1991. In current affairs, in 2018 also it got erupted. So sometimes when they give such questions, you can use elimination. You know first statement is correct. You know the third statement is wrong because of current affairs. So wherever 3 are there, you can eliminate. If such questions are there, wherever 3 are there, you can eliminate and you can land up in coming with the answer. Now this is called as elimination method. Try to find if such questions are there. Is it clear? Then, which of the following phenomena might have influenced the evolution of organisms? So these all are your UPSC questions. What is the correct answer for that? What is the correct option for that? Continental drift, glacial cycles. C. It is nothing but biogeographical realms, biodiversity. So while applying biodiversity realms, I told that glacial ages as well as continental drift theory, which made the species to travel, adapt according to the conditions. So both are there. One and this is how applications are required. Right. Now, this question. With reference to the water on the planet Earth, consider the following statements. The amount of water in the rivers, lakes is more in the groundwater and all. So how to persuade with this? How to persuade? Now, the idea is You won't get all the topics which are discussed in the classroom. So you should have some rough idea where you are having certain questions which you have read from your basic data. You agree with this or not? So even if I take 1 year of the classroom, then do you think that throughout that 1 year, whatever I discussed, only that will come in the exam? So if I say yes, then it is a foolishness, right? So whatever we talk, whatever we discuss, 40% of that can be taken as, right? Now, when such things are there, what to conclude from that? See, these all are from the data. I'll tell you, these all are from the datas. Data in the sense, remember, Earth is referred as blue planet. Blue planet. It means that 70% of that is covered with the water. Water, right? So 70% of that is covered with the water. This is one aspect. Now, out of this entire water, 97% is saline water, which is there in the ocean, right? So here you should remember, 97% is saline water, which is there in the ocean. Then this is 3%, and only 3% is fresh water. This is how you have to make the data. Only 3% is the fresh water, which is available for drinking, irrigation, etc. Now, if you take this 3% as 100, if you take that 3% as 100, then 68% of that, you will find in the glaciers like Arctic, Antarctic, Greenland, etc. in the glacier. This is the first major source of the fresh water. What is the second major source of fresh water? 30% of that is in the groundwater. 30% of that is groundwater. Right. Then after that, when you take divisions of that, you have rivers, lakes, swamps, etc. Now, which will be the next after the groundwater? We have lakes and swamps, and then you come with rivers. Don't presume Ganga, Brahmaputra having huge volume, they are sufficient water. So Great Lakes of America, 5 lakes of America and all. So you'll find such parameters. Now, when you are reading your current affairs and all, you have to make these data as feasible. Now, which is the important groundwater resources for us? Important freshwater resources for us. Important freshwater resources for us. Groundwater or glaciers. Why? Easily available. That's how you should remember. So when you are having thirsty, you can't move to Arctic and bring one bottle of water. You can't move on to Antarctica and carry 2 buckets of water. Easily available water is groundwater. Is it clear? So this is how you have to maintain the data. Saline water and these part. Now, ocean water can also be converted into usable. And that process is referred by a term called as desalination. Desalination. Now, what are the different methods of desalination in your SNT or somewhere? We have something called as flash distillation. Right. Then reverse osmosis. Reverse osmosis. Right. So many ways in which you can convert the ocean water into feasibility, where you are converting them by using a technology. So in this case, technology is required. Right, now here understand, by using a technology, you are converted ocean from source to resource. By using a technology, you are converted the ocean water from source to resource. Now, what is definition of resource? What is definition of resource? Human resource development. What do you mean by resource? Perfect. Anything which is having economic benefit, we refer that as resource. Now, at present, from source, we are converting resources. So that's why land resource, water resource, human resource. In geography, you study about the same thing. Land is there. How you keep that land as a resource. Is it clear? So anything which is economic benefit, we refer that as a resource. Groundwater is a source, but when you use it for irrigation, then the groundwater has become a resource, mineral resource. Companies provide skills, then only he will become benefit, human resources development. Is that clear? So here in geography and all, you have to talk how the sources are converted into resources. And these resources are kept for longer period of a time. We refer them as sustainable resource management. Sustainable resource management. If you understand this one line, you can make your approach in the context of your studies. Is it clear? No. Now, moving down to this question. With reference to the water on the planet Earth, consider the following. The amount of water in the rivers and lakes is more than amount of groundwater. Is the statement first correct? The amount of water in the polar ice caps and the glacier is more than the amount of groundwater. So what could be the correct answer for this? Only 2. Is it clear? No. So this is how you have to make your perspective in the context of your studies. Is it clear? Then tomorrow we'll start climatology. So before that, in the miscellaneous, I'll tell you something about the landforms which are created. Now, when you're reading your NCERT books, I'll just give you one idea that follow this. We'll discuss that very fast. So how many agents of denudations are there? 5. The landforms created by river, we refer them as fluvial landform. The landform created by groundwater, we refer them as karst landform. And the landform created by the wind, alien landforms. And the landforms which are created by glacier. And then the landforms which are created by the waves. So just write the names of these landforms. What are erosional land and what are depositional landforms? When you talk about the fluvial, so in the fluvial you are having meanders. Meandering means bends in the rivers. Meandering is not a landform. Meandering is a process. And this process creates the lakes which we refer them as oxbow lakes. Meandering is a process which create oxbow lakes. Right. So here in the fluvial landforms, we come across V-shaped valleys, U-shaped valleys, gullies, right? Then you have something called as waterfalls, rapids, terraces, potholes. So they all are erosional landform. Depositional, deltas, floodplains, alluvial fans and cones. In the same way, when you move on to the karst landforms, these landforms. Which one? These one. Okay, so see, as in the prelims, there may not be much questions on that, but what we can do is Sunday, I'll explain that. So Sunday, because and I think Saturday, if we complete Sunday, extra time I'll take and I'll explain that. So those who are interested, for them I can explain. So whichever topics you are having, I'll explain that part. So this one you want, right? So I'll explain. It will take hardly 1 hour for me to explain that. 1 hour, 1.5 hours. In that, I'll explain that. Don't worry, I'll explain that. But try to read them in prior. Try to understand the names. When you're reading about the karst landforms, when you talk about the erosional landforms, we have carrains, lapis, sinkholes, swallow holes, caves, caverns, natural bridge. So those are erosional landforms of groundwater. Depositional, stalactites, stalagmites. In the same way, when you move on to the aliens, wind, mushroom rocks, mesas and butts, jugans and erdangs. So those are erosional landforms. Depositional, sand deposits, sand dunes, clay deposits, loess, sand dunes and loess. Now in the same way, glacier, U-shaped valleys, tarns, cirques, hanging valleys, right? Deposition, you are having kettle holes, you are having outwash plains, moraines, we refer them as waves, wave cut terraces, notches, right? Sea arches, stocks, pillars. Deposition, you will have beach, tambolas, spits and hooks, which are referred as a depositional landform of the waves. They will never ask you how they are formed in prelims, but you have to remember what they are. You have to remember what they are. I'll tell you, it will take hardly 1 hour for me to explain that. I'll explain the process, rest you can do it by yourself. Don't get much stressed about that, right? So we'll do on that part. And while defining that also, I'll try to explain this part, that river. So anyway, I'm taking rivers. So these are called as drainage patterns. So in Indian geography, I'll be talking about river drainage system. So there I'll explain drainage patterns also. Don't get much stressed. So I think geomorphology is almost all done here, except that one topic what you are asking. Is it clear now? So today in the afternoon session, we will be doing climatic regions of the earth. Right, so I think at 3 p.m. we'll meet up regarding climatic regions of the earth. Revise properly so that it becomes easy for you to make a point. Thank you.